आता बघा ना मोबाईल सच्ची तिथं मग मी आता बँडविड्थ कमी केली अजून स्क्रीनिंग झाले आवाज जसं पाहिजे तसं येत नाही. हां तुम्ही लॉगिन झाल्यानंतर यूट्यूबला व्हिडिओ दिसतो का?
व्हिडिओ दिसतोय, त्याचा नाही काही प्रॉब्लेम आहे.
पासवर्ड कसं मिळतं ते कळलंय मला वायफायचं. क्यूआर कॅन क्यूआर स्कॅनर कुठून घेतो? मोबाईलमध्ये येईल ना. फिर तो सबको मालूम रहता है अब देखिए
this catchment area around the river that is going to be identified with the help of this aerial photogrammetry. Also, the assessment of the damage, that is in case of any reservoir seismicities, induced seismicity, such type of the calamities you can be observed it because of the features due to the earthquake. Now, landslide is also the major problem is occurred on a road, on railway roads or on a ghat road. Those problems, so before creating those problems on the road, you can be predicted because of the photographs if you have the photograph. And nowadays the satellite images are available area around and if you are monitoring the daily, the satellite imagery is that will be possible to identify. Also the assessment of the damage, and that is possible. Also by using aerial photogrammetry, if you are analyzing those features over the ghat road, such type of the calamities you can be problems or the challenges or is there any action of the plan landslide is also the major problem is occurred on a road, on railway roads or on a ghat road. Those problems, so before creating those problems on the road, you can be analyzing because of the any pollution you have the photograph. And nowadays the satellite images are available and if you are monitoring the daily, the satellite imagery is that will be possible. Now, next part, also the assessment of the damage. That is also by using aerial photogrammetry. So the aerial photogrammetry generally includes such type of calamities. First one is that photographing the terrain or is there any action of the land. Landslide is also the major problem is occurred on railway roads, those ghat road. Those problems. Second aspect is that those problems on the road. You can be analyzing because of the image of the object. And nowadays satellite images are available and if you are monitoring the daily, the satellite imagery is that will be possible. Next part is the assessment of the damage object or process aerial photograph. So the aerial photogrammetry generally includes such type of calculation. First one is that photographing the terrain or is there any action of the land. Landslide is also the major problem is occurred. Also reducing major measurement of the road. Those problems some useful forms such as second aspect is that map problems on the road. You can analyzing because of the image of the you can be reduced and nowadays satellite images are available and if you are monitoring the daily or satellite imagery is that will be possible. Next part is the assessment of the damage object or process photograph. So the aerial photogrammetry generally includes such type of schedulized or requirement one that photographing the terrain or the action of the land. Landslide is also the major problem is occurred. Also reducing major measurement of the road. Those problems some useful forms such as second aspect is that map problems on the road. You can analyzing because of the image of the you can be reduced and now there is a list of mismatches first and if you are monitoring the daily or satellite imagery that will be possible. Next part is the assessment of the damage object or process photograph. So the aerial photogrammetry generally includes such type of schedulized or requirement camera is photographing the terrain or aerial camera. Then accessories. What are the accessories are required for interpretation? You have to interpret the images and plotting the images. What are the accessories are required to prepare the map? So which includes first one is the stereoscope is required. In my first slide, you have seen that was the mirror stereoscope. This one was the mirror stereoscope. So earlier to that, pocket stereoscope can be utilized, but it has the certain limitations. So for getting the 3D image of any pictures, ground pictures, you have to go with the mirror stereoscope. Then stereo projectors are also required. Parallax bar or stereometer, its other name is the stereometer. You have to be called as the stereometer for this parallax bar. So the parallax bar is utilized to observe the elevation difference in between the objects. Second one is the pantograph as well as the stereo plotter. So these are the devices are utilized in the aerial photography. See the photographs. This is the aircraft or called the aeroplane. This is aeroplane. This is also aeroplane. These are the ground features here you are seeing. This is a contour map. Above this contour map, I'm showing you the aircraft. This is the nature. All these are the wings of the aircraft. This is now the total length of this camera. Sorry, aircraft. When it find takeoff actions, so the camera is built with this airplane. And these aircrafts are utilized for the aerial photogrammetry. Then equipments, see here, these are the stereo peer photographs here, particularly I'm showing here. And the same object you are observing, suppose this is one of the objects I am marked here. Same object is also observed on this stereo peer photograph. So why it is called the stereo peer photograph? Because of that, these photographs have collected the same images, same objects. And by looking this object in three-dimensional view with the help of this mirror telescope, you need to find out what would be the distance bounded in between the object and what would be the height, elevation difference in between any two objects. Suppose this is the object, this is the object, then you need to find out parallax of A as a PA and parallax of the second image as a B. So the parallax difference of these two objects as a delta P. So delta P is nothing but PA minus PB. Then by utilizing this parallax difference, we can be able to find out the elevation difference in between object A and object B. So this is a pocket stereoscope, uniform, but it has certain limitations and its eye-base distance is also up to the 75 centimeter. It is just like our the lens. And by looking towards the both the eyeway, you have to be observe the features. But it has a certain limitations. It is not the precise instrument, but for specific purposes it can be utilized. For laboratory experiments, it is very easy to identify the object in three-dimensional view. Similar, these are the mirror telescope, these are the mirror telescope. So these are the different type of instruments or equipments which are available in front of you. It is utilized for interpretations as well as for plotting the entire area. The next aerial photograph. Actually, there are the different types of the photographs are available under this aerial photogrammetry, and the corresponding photographs you have to be called as the aerial photographs. So usually the aerial photographs are classified under the two categories, but one more is the additional part is called as the oblique photograph. First one is the vertical photograph, then second one is the tilted photograph, and third one is the oblique photograph. That depends upon this classification, it depends upon the axis of the camera. So when the camera is exposed towards the surface of the earth and while collecting the photographs, then axis of the camera is totally vertical when you call the vertical photograph. Axis of the camera is somewhat tilted or intentionally it is tilted for collecting the more area. Then it is a tilted photograph and those photographs we have taken it by certain inclination. Then we call as the oblique photograph. There are the two categories, low oblique and the high oblique. So we'll see the more details about these three categories. So in vertical photograph, already I told you, the axis of the camera is vertical. This is the air stations where the air camera is open towards the pictures where the photographs have been taken. All these are the ground points. But the axis of the camera is totally vertical towards the ground. So if the axis of the camera is vertical, then we call this is a vertical photograph. Low oblique, intentionally you have tilted the camera for collecting the images, particularly it is utilized for the a stereo pair photograph. Suppose you want to get the stereo pair photograph, then there is need to tilt the aerial camera. So this is a low oblique where it covers the certain areas than this or more area than this vertical photograph. But high oblique photographs, you see this is red color is the axis of the camera where it covers the larger area. This type of the photograph which covers the larger area. Then look out that is what is the difference in between vertical photograph, then oblique photograph, and tilted photograph. So in case of the vertical photograph, these are the photographs taken with the camera axis is nearly vertical. See, nearly vertical as possible and do not have the tilt more than 1 degree. That is the limitation. Your camera may not be tilted more than 1 degree. Then such photographs you call the vertical photograph. Then vertical photographs are the main way to obtain the photo images for the topographical mapping. That means the mapping. And when the camera axis is perfectly vertical, then the photo plane is parallel. See, that is the photo plane is a parallel to the datum, and the resulting photograph is truly vertical. We call the resulting photograph is truly vertical. Although the vertical photographs look like the maps to lay person, it look like the maps to lay person. They are not true orthographic projections. They are not true the orthographic projection. Rather, they are perspective two views, orthographic projection and the perspective view. You have to be differentiate those in that is what is the plan, what is the map, then you can be able to understand with these perspective images as well as with the help of the orthographic images. The principles of the perspective geometry must be utilized. That is principle of this perspective geometry must be utilized as well as applied for preparing the maps for the entire area of the earth. Then see the photographs of this vertical photograph. You have to observe the different features, the circular in nature. It may be the fan, it may be the pond, or it may be the one of the part of the effluent treatment plant, clarifier chamber, or it may be the one of the part for this water treatment plant. So this is the way, this is the one of the plant. Either it may be the UTP, STP, like this, or WTP. So vertical photographs can produce most accurate maps as the variation in a scale over the area is smaller and no area remains the hidden. There is no area remains the hidden. However, the details in vertical photographs cannot be easily identified as view offers is unfamiliar to the eye. This is not identical. So the unfamiliar to the eyes. Second category of the photographs we call as the tilted photograph. In spite of the precautions taken, small tilt is also required, less than 1 degree and rarely greater than 3 degrees. So your angle should be within that range only. So the less than 1 degree as well as greater than 3 degrees are invariably present, and the resulting photograph or the photo you may call as the nearly vertical, near vertical or the tilted photograph. If the angle is less than 1 degree or if it is greater than 3 degrees. So precise methods which is available for analysis, but this is the more precise observations, accurate observation by this tilted photograph. Third category, oblique photograph. These are produced by giving the camera access intentionally tilt up to the 30 degree. Up to the 30 degree. See, this is inclusion. In earlier case, that is tilted photograph 1 degree to 3 degree. But here you observe those tilt may be more than this, and it is up to the 30 degree is the limited value, but in the forward directions. But in the forward direction. Suppose you have taken the photograph in the direction of the flat, and the aircraft is also moving in the forward direction, and you have collected the photographs of the entire terrain. Then this intent and axis of the camera should be up to the 30 degree. It has the limitations. Then oblique photograph is called as high oblique when the image of the horizon is included, and low oblique when the horizon is not seen. So it's very important part. So the image of the horizon is also included in case of the high oblique. In case of the horizon is not seen, that is for the low oblique, and the camera is tilted in excess of the 3 degree value. In excess of 3 degree. So they provide the information, what are the advantages, what is the purpose behind this, what is the intention behind that. So it is helpful to provide the information of enemy's territory without crossing the borders. So if any territory is attacking to our the area, at least we could get the information, and they could not be crossing the borders. Another purpose behind this oblique photography is like that the pictures can be easily recognized as they are provided, and which is now familiar to the eyesight. Which easily it is identified. This picture is also easily identified. However, some details remains hidden behind the tall structures. Sometimes what happens, you have collected the photographs and some features are hidden within these tall structures, and you cannot be identify the features. Another part is there about the oblique photograph. The scale variation is too large, and therefore preparation of the maps becomes more laborious. That is a tedious job. If the scale variation is to be large, then it's very hectic to you for collecting the photographs. So see the photographs. This is a low oblique photograph. You know, angle is within the range of 1 degree to 3 degree. It may be less than 1 degree or greater than 3 degree, but it has the limitation, not up to the 30 degree. And this high oblique photograph having the inclination of the axis of the camera is up to the 30 degree. See, the coverage of the area is very less with this low oblique photograph, but the coverage of the area is to more with the help of high oblique photograph. Which more area you have to be photographed. Then I want to share you that is what is the difference in between aerial photograph and the map. You have seen photographs as well as you know the map. Then there are certain points where it will differentiate the aerial photographs as well as map. So photograph is a perspective projection. What is photograph? Photograph is a perspective projection, whereas the map is also the and the orthographic projection. The photograph is the perspective projection, and map is the orthographic projection. So here photograph shows each and every details available on the surface of the earth at an instant of the time, but the map shows only the pre-decided details. It is decided. So the pre-decided details essential from the planning point of view. So at any instant, while collecting the photographs, you will be getting the lot of information. But as per our the planning, you have to prepare it map. So that's the actual difference. Second thing is that scale changes from point to point on photographs. Scale is also changes. You have to select the scale. Those scale may not only in terms of 1 as to 100, but it is now in terms of 1 as to 1000, 1 as to 5000, 1 as to 1 lakh. So the scale, but for the map, the scale is remains the constant. So particularly suppose we have to prepare any topo sheet. So the its entire scale is also fixed. If you have seen the topographical map and the scale has been written on this map, the particular scale is going to be fixed. It is not changed. But for photograph, you have collected the photograph depends upon the station point where you collect the photograph, depends upon the flying height. So therefore, this scale on photograph is varying. So the photograph is distorted, that is distortion of the photograph is due to this tilt and the relief. These are the problems and error on the photograph. Whereas against there are no such distortion on the map. So this is advantages over the map. So no distortion on the map because this is a pre-decided map according to the planning. But in case of these photographs, you have to be observed certain errors. If the images are not getting it properly, visibility is very less. Some of the features are hidden because of the obstructions. So that way you have to be observing distortions is a problem. Another difference is there by contrast air photographs shows the lot of confusion. That is confusion, lot of confusions over the aerial photographs, such as the bushes. You know, if this is you are taken the photographs of bush, but as per the photo recognition element, you are looking like the tree, big tree. Then crops, it's very difficult to identify differentiate from the tree, bushes, and this is now the crop, actually image of crop, but you said like that is the trees and the bushes, that is now the confusion. As well as the wearing the ground tones, is a dark tone, light tone like that. Then vehicles on the road, if the only vehicles are moving on the road, if it is a car, sometimes the small buses, mini buses are there, over there on the road. The mini buses we are looking like that a car, which are normally not shown on the map. So that is the actual difference in between the serial photo and the map. So you have to continue the further difference also. Map is a scaled plot of land. So please remember, even though I'm requesting to all the participants, please note down the important points, those points you heard uh, uh, in this faculty development program. If we are seeing that these are the new terms, immediately note down this. Showing the so that's why it is helpful to you while teaching to the students. Definitely, you have to product or you have to explain this point in front of the students. So it is showing possible prominent features, man-made as well as the artificial features. Immediately, you have to differentiate it. Then most of the peoples are familiar with the maps. So they familiar. Immediately they have to identify. Immediately they have to recognize the photographs. Find them and easy to use because they show those details which are essential for the particular purposes. Then another difference, essential attributes such as the place names as well as these are the attributes that are symbols, then heights, etc. do not appear on the photographs. Because of that, on the photo on map, it is possible to prepare the regions like that, the name of that particular area, symbols as well as the heights. You have to be utilize a particular symbol. That is, if there any bridge, is there any road, river, then you can be placed it only on the map. So these things are readily available on the map, but not on the photographs. As maps take the time to produce, they become out of the date by the time when they publish. Their frequent revision is not possible, which is not true with the photograph. Then see the difference. So right now see, this is a photograph and you have to observe this is the map. See the difference. So in this map, you will be getting all the legends, river, road, then contour, then pond, then location of the places, then even though is there any location of the road, railway network, everything is also possible to locate it on the map. But on the photograph, it's very difficult to identify the images on the photograph. But with the help of special techniques, instruments, you can be identify the features with the larger areas. Then coming towards the next part of this presentation, that is how to select the scale. So I want to tell you the scale is nothing but how to set the set, how to set the scale for any map. So scale is ordinarily interpreted as the ratio, you see, that is as the ratio of distance between the points, any two points on the map. That means suppose you have selected any two objects, distance of the two objects on the map to the distance of the same object on the ground. Or in other way I have to call that is ratio of map distance to the ground distance. Ratio of the map distance to the ground distance of any two objects. But the objects are same on the ground. Those objects are visible on the map, same object shall be on ground. So if you have seen the scale, then immediately you have to find out the scale, determination of the scale by taking these two ratios. So the scale of the map on the map is remains uniform throughout this because map is under orthographic projection. Then what about the vertical photograph? So the scale of the vertical photograph is the ratio, please see the difference, is the ratio of photo distance to the corresponding ground distance. So scale for the vertical photograph is nothing but ratio of photo distance to the ground distance of the same object. Similarly, you have to observe that is for the scale of the map or the scale is nothing but this is the map ratio of distance in between the points on the map to the distance in between the same point on the ground. Here you take the photo distance for the vertical photograph. Here you take the photo distance on a map of any two objects. Since a photograph is a perspective view, also the scale is also varying from point to point. So the further variations in the scale are introduced with variation in terrain elevations that is going to be observed. And see, this is the actual now the photograph, and I want to show you the photo plane. This is our the air station. We have taken the photographs here. So the distance from this air station to the photograph is called the focal distance, focal length, gap. And you know, you have taken the photographs on the ground. This is the ground. I'm calling it G. This is the ground features, this hatching line. I'm showing here B, A, B point, A point, C point, and B point was on the ground. And the datum is going to be fixed up with the help of MSL, datum of the ground. And this dotted line is represents as the aircraft is also moving on the terrain to collect the photographs of the ground features. And you have collected the image of this object B, A, C, and the D. So the object B is observed here small b, A, C, and D on photographic plane, having the distance from the air camera as a f. F is the focal distance. That's what we call focal distance. But the aircraft is moving on the ground at the height of h. This is flying height. This is now the flying height of aircraft as well as aerial camera. This is flying height of the aircraft. So object B is also located at the height of HD from that of object C is located at HC. This is the O point in the axis of this photograph, or we call it the principal axis. This is the center of this photograph. It is located here. So OA, OB, these are the objects. Here the objects. This is the photographic plane. A point is located at height of HA. B point on the ground is located at the height of HB. So this is the way you have to declare this is actually the scenery. Okay. And this is see the colored image, then you can be identified very easily. And this photographic plane, this is now the positive photo. Also the negative photo you can be worked out, or you are getting the negative images also. So this is the photographic plane, and you will be getting the images of the object B, A, C, and D on this photographic plane. These are the height of the objects. You know that? Okay. Chapekar sir, Chapekar sir,
Yes, sir.
hello.
Yes, sir.
Whether it is going on smoothly, whether
Yes, sir.
audio
Yes,
is
your audio
clear,
is also clear and presentation is also
okay.
visible. Yes.
Yes, sir. Okay, thank you. Shall I continue? Huh? Okay,
Yes, sir.
okay, I will continue. Okay. So datum scale, regarding with the datum scale, what do you mean by the datum scale? This is the scale, or how to understand the term datum scale. This is the scale effective over the entire photograph if all the ground points are projected. If all the ground points are projected vertically downward on the MSL. So already I told you MSL is also located as a datum before being photographed. Before being or before photography, you have to find out the scale effect over the entire photograph if all the ground points are projected vertically downward on the MSL. Then on a different way, you have seen the scale of map, you have seen the scale of photo, you have seen the scale of map, that is the map distance to the ground distance. Or scale, in case of the scale of the photographs, you have seen the photo distance to the ground distance. Similarly, with the help of this particular photograph, datum scale is nothing but F by H. H is the flying height of the aerial camera or flying height of the aircraft, and F is the focal length of the camera. We have seen in the earlier diagram. So F is the camera focal length. H is the flying height of the aircraft or the camera above the accepted datum. So the points, just one minute, points A, B, C, and D. एक मिनट. हाँ? नाही नाही माझं चालू आहे माझं सेशन चालू आहे इथे यायसाठी सांगा तिथे सांगितलं आवाज करायला हो हो so point A, B, C, and D, which lies at the elevation of HA, HB, HC and HD above the datum are image on photograph as a small a, small b, small c, and small d. Then from similar triangle, you have seen once again, you have to look out the diagram. Because of that, I'm not possible to again dictate the previous diagram. So please try to draw the sketch on your uh, notebook so that you can understand the further derivations. So please draw the sketch. It's my request to all the participants. Please draw the sketch so that you can be understanding aspects very clearly. All of you draw the sketch. Okay. And let me convey if your drawing is completed. Let me convey whether your drawing is completed. Hello, whether it is complete? Have you completed this? Have you completed this?
Sir, they are not allowed to talk
Ah,
here.
yes.
I think they might have
But at
completed
least
this
you
figure.
take the review.
Yes.
Okay, at least you take the review, or they can put up in chat box. Because of
Yes.
that, the further derivation is based on this diagram,
Okay, sir.
so that they can understand the whatever the derivations with the related equation. So they can put up in the chat box if
Yes.
they have completed the diagram.
Participants, if you have completed the figure, please mention it in chat box. Yes, sir. There is one response. You can continue now.
Okay, okay, okay. Whether they have finished?
Yes, sir.
Okay, okay. Immediately I shall go with that. So that's fine. Okay, let us move towards the further part. So therefore, the scale of the photograph is nothing but that is a vertical photograph. A is equal to SA, which is now equal to the ratio of focal length to this line height. So you have to look at H minus HA is nothing but H is the capital H is the flying height and HA is the height of the object A above the datum surface. Then scale can be worked out as FYC. F is the focal length of the camera divided by H minus HA. This is applicable for the vertical photograph. Now you have seen this part that is a small triangle LEAB and LEAB and repeating AB by AB. This is the AB nothing but distance from the object A and the B on a photograph. Capital A and B is the distance in between object A and B on the ground. So the LA and the LA, capital A, this is also the same ratio because similar triangle you have to be observed. So LOA, so again similarly you have to work out with this A of this. So equating the LHS of equation number 1 with LHS, and this is the RHS. RHS is on the two parts. You have to equate this. Therefore, AB by AB is equal to F by H minus HA by consideration of the same triangle. And this ratio AB by AB is nothing but the photo scale related to the object A. Therefore, we can mention here as A. Next, similarly, you have to obtain the photo scale at B object. Same way, you have to find out SB, F by H minus HB. Similarly, at the point C, you have to find out F by H minus HC. So, in general, scale at any point on vertical photo shall be S is equal to F by capital H minus the small h. Please remember this equation. S is equal to scale of any vertical photograph. It is now equal to small h by capital H minus the small h. So where h is the average elevation of the terrain above the accepted data. Then flying height and the scale. You have to observe these are the two photographs. So it indicates, it shows the lower flying height and which is if the I am telling you as per the scale is nothing but S is equal to F by capital H minus small h. Then lower the flying height, you see lower the flying height means this is H value is lower, then greater the scale of photograph. Why? Because of this is a denominator, this is a numerator, always S value should be more. Therefore, the scale of photograph is more. Then what type of the photographs we have seen it? This is the photograph we have seen it. When the scale of the photograph is the greater. Then vice versa, if the flying height is higher, means denominator is more, then definitely the scale of the vertical photograph is reducing. Therefore, higher the flying height, smaller the scale of photograph. So, that means the more area you can be able to cover it with the higher flying height. But the scale of the photograph is small. So, please note down this point. Then other methods can be utilized to determine the scale. So by comparing the photo distance and the ground distance. So photo distance by ground distance. Scale can be represented as 1 as to n or 1 by the L, where this one indicates that is the distance on this photograph between the 2 points A, that is, sorry, small l and the capital L. So the small l represents distance on the photograph between the 2 points A and B having the same elevation small h, and capital L is the horizontal distance between the same points on the ground. Then this is another method to determine the scale. How to determine the scale? So by comparing this photo distance and the map distance. So the photo scale to the map scale is equal to the photo distance to the map distance. Suppose any one of the parameters is unknown, then immediately you have to find out the photo distance. If this is unknown, then you can find out the photo distance. If the map distance is unknown, if you are doing this three terms, then definitely you have to find out the map distance. So that's why this is another method is also more important to find out the unknown part. So I want to show you one example. I will go too fast. Because of that, I am not able to spare much more time while look out these problems. This is for I am taking you for the example. If the line AB is measured 9.3 centimeter on photograph taken with an real camera having focal length of 15 centimeter, same line is also measured 3.1 centimeter. So 9.3 centimeter on one photograph, but on a map, same line is also measured as 3.1 centimeter for this AB on the map, and the scale of map is given 1 as to 50,000. Then you can be able to find out the flying height, H value of the aircraft if the average altitude of the ground is 250 meters. That is average altitude of the ground is 250 meters. Therefore, solution is the photo scale to the map scale is equal to photo length of line AB to the map length of the same line as per the previous equation. So you have to put up all these values, yes, then scale 9.3, 3.1 is the measurement of distance on photograph and on the map. Then you will be getting the scale, yes, value is equal to 3 by 50,000. But now the way for the scale can be represented as in terms of 1 as to n or 1 by n. So using this equation, you have to determine the scale. So the S is equal to F by H minus H minus. So finally you got the answer. Substituting this and the flying height of this aerial camera or aircraft will be getting as 2750 meters. So this is the way the scale of the photograph, scale of the map is helpful for find out the flying height as well as find out the scale. So any unknown parameter can be easily find out with the help of this. So ground coordinates, another aspect about the vertical photograph. So ground coordinates of a point. So we'll see the diagram. This is the photographic plane where you collect the objects, that is A, B, like this. And angle made, this is the point. We call this is axis of this camera. This is the photographic plane. Then this is the focal length. This is the flying height H. This is the datum. These are the objects. So you have to be observe the coordinates, x coordinate and the y coordinate. I want to share with you. Suppose this is the photograph, and you know this is the principal axis, is the photographic plane. All these are visualized, and your point is located here. So the on this axis, this would be represented if object is A. This would be the XA coordinates of the point, and this would be the Y coordinates. So this is Y. So this point on a photograph represents the two coordinates that is XA as well as the YA. These are the coordinates on photograph. So this is the way you see, that is XA, YA. Why it is helpful? Because of that, by knowing the photographs, immediately you have to identify the height of the object without doing any measurements on the ground. Only by using the photograph, you have to you have to find out the height of the object. So all this information is also given here. I am not taking too much time here describing this. And the problem shall be asked to you. If in front of the students, if you are solving the problem on this photogrammetry, this such type of the problems are to be asked. Or on field, if you are doing the work on field, then immediately with the help of the photographs, you have to identify the features as well as you have to find out the height of the camera as well as you have to find out the ground distance in between any two objects with the help of the photograph. So just I have to dictate this problem. If any two points A and B has an illumination of 280 meter and the 650 meter above the datum, say above the datum, the coordinates of A and the B measured on the photographs, the coordinates of A, see the point A and B having x coordinate plus 3.54, y plus 3.54, B is minus 2.58 centimeter and the plus 3.9 centimeter. So according to the coordinates, this I will show you. See, suppose this is the first quadrant, almost x and y coordinate positive. Here almost the x and y coordinate is also negative in third quadrant. And here you have to observe y coordinate is negative, x coordinate is positive. Here is also the x coordinate is negative and y coordinate is positive. According to the sequence of the quadrant, you make it the sign. Then x coordinate with respect to the point A, B plus 1.75 and these are the points. And our main question or the aspect is to find out the length, distance in between point A and B if the flying height or altitude is 2500 meters above the data. Then I want to show you here the how to solve. Substituting all these values, length of AB is nothing but square of xb minus x square plus yb minus y square. Substitute all these values in this equation, then you have to find out the xb. So by using this equation, you know this focal length and the distance. And for the xa, similarly you have to find out the x coordinate. You know this, it is given, and yb is also given. And finally, you got the answer. See, length of AB is equal to 644.605 meter is our answer. Then distortion, some problems you have to be facing because of this relief displacement. So this is a diagram. I am telling you relief displacement is nothing but the shifting of the images on the photograph or movement of an image from its theoretical data location caused by the object's relief, and that is now in terms of the elevation above or below the datum. So relief displacement occurs along the radial lines from the principal point. So this is one of the derivations how to get the relief displacement shifting of the image. And finally, I want to tell you relief displacement is nothing but ratio of R is by capital H is the final equation. R is the photoradial distance from the principal point to the image of the top or the high point. H is the height above the datum of the top or high point, and capital H is the height of flight above the same datum. So the elevation of relief displacement used to locate the datum photographic position of images on a vertical photograph, and you compute the height of vertical objects such as that is height of the building, height of the church, people, or radio tower, power poles can be easily find out. Also to determine height using this equation, already you have seen the equation of both top and bottom of an object. Relief displacement equation is particularly valuable to the photo interpreters who are usually interested in the relative height other than the absolute elevation. Then another part, stereoscopy and parallax. What do you mean by the stereoscopy and parallax? So the effect of distortion existing in a single photograph may be limited to a large extent by using the stereo pair photograph. So why the stereo pair photographs are to be utilized? Because of the any distortions are observed in any one of the photographs, those distortions can be eliminated by the technique of stereoscopy. So by viewing the objects, so the stereoscoping, the stereoscopic view is nothing but to seeing, looking the object in the three dimensions with the help of mirror stereoscope. So the instruments we have to utilize for the stereoscopy and mirror stereoscope especially utilized to look out the object in three-dimensional view. Then see, this is stereoscopic regions where the object A and the B, and finally you will be getting the height of the object AB. If this is the left eye and this is the right eye, through the mirror stereoscope you have to be observed, bisect, that is focusing this object towards the stereo pair A and B, and finally you will be getting the 3D image. So the I1 is the parallatic angle with the object A, I2 is the parallatic angle with the object B. So those angle is set with your the eyesight. So this is now the eye-based distance. This is now the eye-based distance, and through the mirror telescope, you have to look out the object. Then what do you mean by the eye-base? Eye-base is nothing but optical axis of the two eyes of an adult are separated by a distance of 63 to 759 millimeters. Sometimes it may be up to 75 millimeters. Average distance is eye-base distance. We call the eye-base distance. Distance bounded in between two eyes. Then parallax angle or angle of parallax, the angle subtended at a point by the eye-base is called the parallax angle or angle of parallax. Then greater the parallax angle, greater is the depth of perception. Principle of depth perception by comparison of parallax angle is extremely useful. So using this principle, photographs can be analyzed stereoscopically. Then height of the object can be possible to find out. Variations in the terrain can be determined. Man with the normal vision can discern the parallax angle changes even though for 3 seconds. Distant objects, this angle becomes smaller, resulting in a smaller depth of perception. If the object is at a distance of 450 meters, parallax angle becomes 30 seconds and the perception here. So the depth, you will be getting the 3D image that depends upon where the perception can be easily increased artificially by widening the eyebase by making the use of prismatic binoculars or the mirror adjustment. So the stereoscope is the instrument utilized to observe, look out the objects in three-dimensional view, and you can be identify the features with the help of your eye-based distance. Stereoscope permits viewing the photographs stereoscopically by enabling the left and the right eyes to focus in the object, and you will be getting the 3D image of the object. Okay, see, this is the left eye, this is the right eye, same diagram, parallax angle. This is for the lens telescope. This is the lens telescope. Then this is the mirror telescope. Already you have seen this mirror telescope. So the mirror telescope you can adjust it and you will be getting the 3D image. Then accessories for the mirror telescope. These are the telescope where you have to look out the object. That is the binoculars through this lens. These are the parallax bar. This is the tracking device. This is illumination element. You see, these are the photographs. This is the parallax bar. This is the whole accessory. You can being built it in one place. So the stereoscopic parallax. So what is this terminology? So parallax is defined as the apparent displacement of the position of an object with respect to the frame of reference due to the shift in a point of observation. So this apparent motion of the object is due to the changing location of the observer. Point closer to the camera will have the greater parallax than the points away from the camera. Movement of an image across the focal plane between the successive exposure. Successive exposure must be required. So you know the camera is going to be exposed for the same object. Then you have to be called as a successive exposure while taking the photograph with the direction of the flight. Thus measure the parallax. That direction must be established. So this is the photograph. This is the direction of the float. First photograph, second photograph. Then for mapping those photographs, you know the principal point of first photograph as a P1 and the P2. While look out the images of these two photographs through the mirror telescope. So first of all, you have to focus the principal point on the first photograph. P1 point can be reflected over the image. Second photograph as a P1 dash. Secondly, you have to put up the finger over the P2 point on the second photograph. The image of the P2 can be visualized on the first photograph as a P-2. And these are the conjugative principal points. Then flight directions, I will go fast. Stereoscopic measurements also can be possible. Parallax of point can be measured with the speed accuracy while viewing these objects through these binocular visions. Parallax bar or stereometer consists of the two glass reticles attached to a rigid bar. So these are the information given towards this stereoscopic technique, and the difference of this object will be determined. Another instrument I will show you, this is stereo plotter with mechanical plotting system, which is available with the photographs. Also with the digital plotting system with the instrument. Then with mechanical plotting system, digital coordinate recording system. So this is the way I have to finish my topic.
Okay.
So I have to end up with my today's session.
Yes, sir. Participants, is there
Yes.
any questions or queries regarding this session? I think there are no questions, sir.
Okay, thank you very much.
Sir, on behalf of our institute, I mention my words of thanks to Dr. Nangre, sir, for sharing his knowledge about photogrammetry and having continuous support in this FDP. Have a nice day, sir.
Thank you, thank you. Thanks to organizer, thanks to organizing team. Thank you, Kaka sir. Thank you, Kapekar sir. Thank you, Anturkar sir. And lot of thanks to Giran sir, principal of AISMS Polytechnic. Thank you.
Yes, sir. Participants are requested to fill
Yes, sir.
attendance link shared in this chat box. There is some change in